Guys, pay attention. So I have a graph. How fast did the person how fast did the person walk during segment A? Yes. A foot per minute. So if we have a distance time graph, the slope is going to be our velocity or speed. We can also look at the equation. Speed is equal to distance over time. So they started at 10 feet and they moved to 30 feet. So we would do 30 minus 10. And they started at 0 minutes and it took them 30 minutes to go that distance. So we would do 30 minutes minus 0 minutes. So that would be 20 feet divided by 30 minutes. Which would be 0.6667 feet per minute. So the distance that they traveled, they went from 10 to 30. So our rise was 20 feet. Or run goes from 0 to 30, so 30 minutes. So the slope of a distance time graph gives us the speed. That makes sense? Also, make sure whenever you're doing this, you actually check what the units are. This is in feet per minute. So this person is moving quite slow, less than a foot every minute. So, how far did they travel in segment A? How would you solve this one? And how to put your math back on. So remember that velocity is equal to distance over time. So we're trying to find distance. So distance will be equal to the speed or velocity times time. So let's look at segment A. What is the speed? So yes, there's a constant 30 meters per second. So our speed is 30 meters per second. And what is the time? So distance is equal to speed, which is 30 meters per second, times a time of 20 seconds. That's a total of 600 meters. What is the acceleration of segment B? So remember the equation for acceleration? Acceleration is equal to what? What's the equation for acceleration? That's speed or velocity. What about acceleration? Yeah. So it's final velocity minus initial velocity over time. So what is the final velocity? So final velocity is 10 meters per second. What is the initial? So the initial is, so here's VI as your VF. So it's minus 30 meters per second. And what about the time? 10 seconds. So 30 minus 10 is 10 seconds. So 10 minus 30 is negative 20 meters per second over 10 seconds, which gives us negative 2 meters per second squared. Remember, acceleration is going to be in something like meters per second squared. So again, if we have a velocity time graph, the slope of a velocity time graph represents acceleration. So the slope of this line is acceleration. So we had a rise, technically it's more of a fall, of negative 20 meters per second. And we went over by 10 seconds. So we went down by negative 20 and we went over by 10. So the slope of that line is negative 2 meters per second squared. The rise over the run. Does that make sense? So make sure one of the first things you do is realize, are we doing a velocity time graph or a distance time graph? So we have segment A, B, C, and D. So suppose this graph represents a student walking toward a classroom. How long did it take the student to reach the classroom? So how long did it take the student to reach the classroom? So this graph is representing them walking toward the classroom. 50 seconds. Is it 50 or 60? So they stopped moving at this point right here. So we assume when they stopped moving, that's when they reached the classroom. So it would be 50 seconds. During segment C, Elena, put your phone up. So during segment C, how fast was the student walking at? And this is supposed to represent this at 35. So remember, speed is equal to distance over time. So our distance, and again, this is supposed to be right here. Our distance, it went from 20 to 50. So that's a distance of 30 meters. We can also subtract it, so 50 meters minus 30 meters. We're looking at the initial, that's supposed to be 20 to 50, so 50 minus 20. And we're going a time from 35 to 50, so that's 15 seconds. So going from 50 seconds, so going from here to here, and here to here. Or you can look at rise of run, which is 30 meters per 15 seconds, or 2 meters per second. What is the average speed? What does average speed equal to? What's the equation for average speed? Anyone remember? So that's total distance over total time. So again, we're only looking between when he started walking and when he reached the classroom. So the total distance is 50 meters. The total time is 50 seconds. So his average walking speed would be 1 meter per second. We can also ask, how far away is the classroom? Which would just be 50 meters. That was a good point for the remote learner. Code word of the day is derivative. Code word of the day is derivative. Yeah, be quick. Alright. When was the car stopped? So, when the speed is equal to 0. Car stopped when the speed is 0 meters per second. So you can either write it HI with a bar, this means line segment, or you can write it as H dash I. When was the car accelerating? Which line segments are as when the car is accelerating? A, B, which one? And E and F, and I and J. Technically, C, D also. This is when it's decelerating, but decelerating is just negative acceleration. And G, H. So these two are technically negative acceleration. I know one of the PowerPoint or that worksheet we did actually made the deceleration and acceleration be different things, but technically we include deceleration as just negative acceleration. When was the car moving at constant speed? So B to C, D to E, and F to G, and J to K. Note, HI is constant speed of 0, but the car isn't moving. So HI is not included because the car isn't moving. But it is constant speed of 0. But instead asked, when was the car not accelerating? We would include HI. So it would be DC, DE, F, G. Now we include HI. What is the acceleration? Of line segment EF. So what is the acceleration of line segment EF? So looking at here, we're looking at this line segment. It goes from 20 to 50. So it had an increase of 30 meters per second. Let me drop more light on this. So increase right here. And then it went over by 2. Supposed to be from 10, 12. So from 20 to 50 meters per second, and from 10 seconds to 12 seconds. So acceleration, you can look at the equation df minus di over t. Our final was 50 meters per second minus our initial 20 meters per second over a time of 2 seconds. Or you can just look at rise over run. So it went from 20 to 50 in 10 to 12 seconds. You can just look at rise over run. The rise was 30 meters per second. The run was 2 seconds. So 15 meters per second squared. Any questions? So the plan for the week is this. Tomorrow I'm going to review. I'm going to have a test Wednesday. Everyone getting the graph? Is the graph easier? Would y'all like me to go over any more examples? Or y'all good? Alright, that's it for today.